Hi, this is Saeema Ahmed-Kristensen, a professor of design engineering and director of Digit Lab from the University of Exeter. Thank you very much for the nomination for the Impact Award. We're very pleased. We're going to talk about AI, big data, and how we innovate and address stakeholders' needs through a case study with See.Sense with Irene McAleese, who's here with us. To start with, I'm going to just briefly say what Digit Lab is. And this is a UKRI, which is a funding body from UK, funded centre on digital economy and research. We are looking at 5 different themes, but the focus of this one is on digital innovation and understanding how we adopt digital technologies. What we're presenting today is looking at data and AI to support growth, impact, and transform organizations. So why we might start the question saying, why do we want to understand and look for a process? Well, we're first going to step back and think about how innovation takes place. Product development typically takes place from starting by thinking about a challenge, a need, or a market need, or about having the technology and then having a push with that technology to identify where there's a need. And there's similar processes for designing services or product service systems. So the question comes about, if you've got big data and you've got AI, how do we innovate? And more carefully and more importantly, how do we innovate and ensure the needs of stakeholders are addressed? Because we're starting now with a different starting point. So to try and understand this question, we first explored how big data is currently being used to develop new products, new services, and to innovate. And we did this by undertaking a 10-year review of articles and papers from which we could understand how different researchers were using data, which part of the process sensor data was being used and collected. And from this, we first developed a framework, and this is called the Data-Driven Design Framework, where we identified 7 different activities where data can be used to support innovation. And one of these is generating ideas, which is what we're doing here. But you could also see it could be about maintenance. And we'll talk about maintenance of infrastructure, maintenance of product systems, or customizing products and systems. So from here, we developed a case study in close collaboration with See.Sense. I'm going to just introduce Irene, who's the COO.
Hello, my name's Irene McAleese. I'm co-founder and Chief Commercial Officer here at See.Sense, and we are a cycling technology and data company based in Northern Ireland and working with local authorities around the world to use data insights to improve safety and cycle infrastructure planning. And we were delighted to have the opportunity to work with Saeema and her team at Digit Lab on this case study, and look forward to getting into that with you.
Yeah, we've fortunately been partnering with See.Sense for a period of time, which has allowed us to trial and develop processes for data-driven innovation and to understand how AI and data can be used to innovate while thinking about the needs of stakeholders. So in this example of See.Sense, which Irene will elaborate in more detail in a minute, See.Sense collect data from smart bike lights, intelligent bike lights that you can use on your bikes or can be used through GPS devices and trackers. And in this project, we worked with representatives of Dublin Council, Moby Bikes, a bike share scheme, as well as digital innovation teams. The kind of challenges that are explored and why are we looking at this data is one, if you want to encourage young children to take up cycling, there's very little evidence of how to do this, how to support them, how to collect that data and bring it together. If we want to encourage cycling, we know the infrastructure of cycling is very important. People consider safety, they want to know there's good routes, and that information needs to be shared with, for example, local councils who can then use that information to design infrastructure that is best suited for safety of cyclists, but also to inform them of how those roads can be maintained to support other users. the third challenge is understanding how you can optimize the cycle lanes and the networks, not just for safety, but also for usability, and how that information can be gathered and presented to cyclists. So what we are exploring is how sensor data and AI can be used, for example, to support behavior change, encouraging cycling, or encouraging your children to cycle, to inform infrastructure management, in these cases, the roads and the cycling infrastructure, but also to innovate and inspire new products and service ideas, which include data dashboards. It is quite important to highlight, and I'm sure Irene will pick up on this, that this data is not currently being collected, and understanding how this can be combined and being of value to different users is a challenge and a big challenge to address. So as part of this process, we had a number of steps. And the first step was to understand what data is available and identify the capabilities of the data being collected. So I'm just going to hand over to Irene to talk through these.
So thank you, Saeema. So I guess firstly to give you an idea of the type of data that we collect at See.Sense. So as Saeema mentioned, we have smart bike lights. There is also a Summit GPS and sensor tracker. So this is in-house technology developed by See.Sense using our patented sensor technology. What we're doing is taking a really high frequency, so 800 readings per second that we get from the devices, and we use AI as well on the device to process all of that data in real time. So essentially, the data that we're getting is really detailed telemetry data that can look at things like the swerving patterns and the braking patterns and collisions, even the road surface that the cyclist had travelled over, as well as the sort of more sort of basic things like that you would get from the GPS reading, like the speed and dwell times. So really, it's a new data source that's not currently available for cycling. And this is the exciting thing, is that what we're doing at See.Sense is not only, as we'll see in this case study, taking in other existing data sets, but blending it, enhancing it with these new insights that are available through our patented sensor technology. So as I mentioned, there's swerving, braking, road roughness data, collisions, movement patterns, speed and dwell times. But this is all the sensor data, but importantly, that is also enriched by the subjective data that is gathered through the See.Sense app, where a cyclist makes a report. So they can drop a pin in the app and mention, particular sections of the road where they felt unsafe, had experienced a near miss or a pothole, this kind of thing, which adds this sort of subjective layer of data alongside the objective sensor data that's gathered. And as we'll see, that combination can be really powerful when we start to overlay some AI onto that.
So once we had all this data, so the first part of this process was understanding the data that's available and understanding who and how it could be of value. So we took all these data sets to understand and identify what we would call stakeholders and map these stakeholders, and then bring these stakeholders together through workshops to then further develop ideas and innovate on what sort of value can be obtained from the data and how these data sets, as Irene highlighted, which can be blended, can be combined with other data to provide value to users.
So the project was held in Dublin with UKRI Council, which is one of the 4 major councils that make up Dublin as part of the Smart Dublin area, in partnership with Moby, which is a bike share operator that is in the Dublin area, but it's interesting one because they also work with employers. They have a large business district with the employees like from Google and other tech companies, and then they also have those bikes being used by couriers. So there was a real mix of different users from public bike share couriers and corporate. So that was ideal to put the See.Sense devices out on those devices, and obviously the other partners being ourselves and University of Exeter through DigiLab. And what we really wanted to do, as Saeema said, was to unlock the potential and show how connected bikes can start to generate a new source of data which could have a powerful impact for cities. So as I mentioned, we put those devices onto the Mobi bikes. So there were actually 60 devices deployed. And we also had an existing data set as well from a previous project involving a couple of hundred cyclists using the bike lights. So there was a combination of the two data sources we could use there. And then there were co-design workshops held, which Saeema will go into more detail about, and then with the output being the data dashboard development, which I'll cover a little further as well in the presentation.
So as part of this workshop, we brought together the stakeholders across those organisations that we mentioned, Mobi, the shared bikes, the Dublin councils, as well as digital innovation team together. And prior to the workshops, we had done the mapping and identified the relevant stakeholders. So during these workshops, they were presented with the data insights from the See.Sense team and understanding for them what the value is and potential value from each data source that's been collected. They were then introduced to the data-driven design framework. And from here, we then organized the teams into groups to identify specific challenges related to cycling and active travel. For example, encouraging the children to cycle, so that's a behavior change challenge, or looking at infrastructure to encourage active travel. From these, working together with the stakeholders, a number of early concept ideas were generated. And these ideas were then presented to See.Sense, who were also present as part of those workshops, to take further in terms of developing prototype dashboards, which could then be brought back to the individual organizations as part of the iterative design process. So the value of this part of the process was identifying which data would be of value, how it can be combined, and how it would need to be presented in a dashboard, informing the type of decisions, the type of ideas that each organization or stakeholder was interested in. So this part of the process also included going through a canvas that we've designed, which allows the understanding the mitigating effects or potential effects and impacts of collecting data on individuals and organizations to ensure that any potential negative impact is considered at an early stage. It also understands what the values are and what the resources are available in order to take the data all the way through to an idea. So after the internal workshops and these stakeholders and developers, this was then handed over to See.Sense to look and develop the prototypes and ideas that were presented before they moved on. And I'm just going to hand over to Irene to talk through some of these.
Yeah, so out of the workshop, I guess, coming back to the challenges that Saeema mentioned right at the beginning, what they highlighted in these workshops, a lot of the challenges they're having. One is that they don't really have a lot of crash data in Dublin, even less than in the UK. They've had an issue with actually accessing that due to GDPR, so they just don't have any information about where crashes are happening at all, which is terrible if they're trying to do proactive planning. The other thing that they talked about was the limited data coverage that they have currently. So they might have some counters in some locations, but there's really a lot of gaps across the network that they just know nothing about. Then the data that they do get, say from current share bike schemes, for example, they have just very basic data. So it could be just the GPS or the movement of the bikes, not even the journey, but just the number of trips taken. So again, very limited insight. And then they talked about challenges as well, about data that they get from surveys and apps being skewed to particular groups, or surveys just being time-consuming and costly. So, so I guess one of the pain points is, yeah, what can we do with the existing data sets, but acknowledging that they are already a bit thin on the ground. Looking at the See.Sense data and thinking about the current data sets that they have, this is really a wish list of, what would they love to see our data start to help them answer. And this was so important as part of this process, because ultimately, as See.Sense, as a technology provider, we are not the transport planners, and this process was super useful in understanding their needs, so we could really dial in what we're doing. So they talked about understanding safety, how to prioritize it, also getting kids on bikes, not only in their neighborhood, but traveling to school, active travel promotion in general, just trying to get more people onto bikes and using the network, and then also evaluation. So more and more local authorities are being tasked with being able to monitor and evaluate the impact of what they do. All local authorities are working to tight budgets and have to do more and more with less. And so the requirement for monitoring the impact of any intervention, showing that they are gathering the evidence to show that they have had an impact, was really critical to them to be able to then justify further investments down the line. So this was really useful information that came out of these workshops about their core needs. They would love to have more data and more insight into how they can tackle. So what we did following the workshops was to take away a lot of this information and start to look at a common theme that would be running through a lot of those different areas. And given that, there was a rather large wish list, shall we say, that came out of those 4 particular things within the time frame of this particular project, which we finalized at the end of last year. We decided to tackle the safety element, because really it's a core theme that runs through all of those issues that were highlighted, because ultimately, if you want to make cycling attractive, you need to make it safer. Having information about how to improve routes will encourage more people to get onto bikes, and so there's a promotion element in there as well. What we were able to do with the See.Sense data was bring in a lot of other contextual data, and then start to analyze all of the different dimensions that could help prioritize where those risky areas are. So this would be looking at things like the size and the scale of the event. So how widespread is the issue? The user impact being, how many people is this affecting and how often? The hazard complexity, is it just a bump, or is it a combination of the swerving and the braking and the roughness? The acceleration severity, so how violently are the cyclists being disrupted? And then the time, so looking at just the time of day and how that can impact in terms of traffic levels and timing there. So taking in this information and being able to combine that with the perception data that I talked about before, with the dropping pins in the app, also the number of reports, allows us to then using the AI, prioritize hazardous locations that were riskier along the network. So really automating this, but with a really nice tool. The second thing that we did, if we can move to the next slide, Saeema, is we we also looked at how we could understand those journeys. So using the AI to actually categorize the different journeys by type. This is really very interesting to local authorities to start understanding, was this particular journey used for leisure? Was it a commute type journey, or could it be mixed? And it's really great that we can use this AI to observe patterns in the data and automatically categorize it by the type of journey. So if you take commuter, for example, their journeys often have a steady but above average speed, a clear focus on efficiency, there's a strong concentration during the peak hours and weekdays, their trips and origin destinations align with, you know, business parks, transit hubs, commercial centres. So using AI, we're scanning all of the data, you know, to elicit and to categorize the type of predicted journey type based on a range of those different factors. And this is crucial for, you know, when local authorities are wanting to, you know, encourage more people to commute by bike, for example, we can see where those commute journeys are happening, what issues are happening on their routes. And this slide is really talking about then more how we use contextual data as well, layering this in. So we can bring in things like the weather, collision reports, infrastructure design guides, and even messages and things that are out there on cycling forums and social media. This can all be brought in as context for the AI tool to get more richness around what could be seen in the See.Sense data at a particular event. This slide is actually just showing you how much data came in off those 60 bikes that were deployed through the innovate project, and then that existing data set that I talked about using the bike lights. So as you can see, there's really quite a lot of data that was gathered by See.Sense in this particular area, looking at that 36,000 kilometres worth of data and 46,000 from the bike lights. But yes, this is really coming back to now the prototype that we have developed following the workshops that Saeema facilitated, Saeema and her team facilitated. So this is an example of the 3 key areas that we prioritize within the time frame of this project. So firstly, hotspot analysis, looking at those key issues, automatically identifying those areas. The second part is the abnormal events. And this is really interesting. This is that before and after piece, that monitoring and evaluation piece, because what we're doing there is actually identifying where there's been a change, and then having a way to then show where after that change, why it's different, and also making suggestions as to the reason why that change might have happened, and giving more based on the context. And the last thing, and I can give you some examples as we go through here a bit further, but the last area that we've looked at in this prototype is also the changes in the popular routes. So which routes are popular, why are they popular, and have they changed in their popularity based on some kind of event that's happening? This is taking the hotspot example. So looking at that first one, if you look at the picture there in Dublin, you can see there's a bike lane next to the black car, and it's actually the car you can see is actually encroaching over the bike lane there. And this was picked up through the data, through the swerving and braking, but also through the pins where cyclists had dropped and talked about that issue. So we can see frequent driver conflicts, braking and swerving spikes, rough surface signals, pointed to drivers encroaching on the cycle lanes. We also fed, as I mentioned, the cycle infrastructure guidelines for Dublin, and it indicated that there were cyclist vehicle conflicts because of the weak infrastructure design, the unsafe turns contributing to this conflict with the cyclists. The AI could pick up that it's happening during weekdays at AM peaks, and it's an issue for commuter cyclists. It can even see when in the year, from the seasonality, August, September, is it due to the uplift in the weather, the improvement of the weather, more cyclists being out on the road, and even makes some suggested treatments. Again, with the abnormal event example, this is showing this improvement actually that they made in O'Connell Street, Abbey Street area showed a 40% reduction in the brake and swerve events. They can show that conditions have improved steadily from June, and that this is an upwards trend showing the impact of the improvement of that piece of infrastructure. And lastly, if we go on to the next slide, the popularity change example, this was actually showing a route which sustained its popularity throughout the year, which they were very happy to see because they had made an investment on this piece of infrastructure. It was able to pull in information about the weather, when the peak volumes were happening, even the condition of the maintenance of the road, that it had smooth surfaces, it had clear markings, and this was potentially a contributing factor to the popularity of the route. So yeah, and I'll hand back to Saeema now, but essentially that is the prototype that we built following that workshop, which is very aligned to the needs that were identified by the users.
And the brilliant thing about part of the work is that it's been adopted by Milton Keynes Council, and as I understand, Irene, it will also be adopted in Australia, in Sydney and South Coast shortly. So as we highlighted in our presentation, there are a number of challenges with the type of data that's currently available for cycling, or how it informs maintenance, how it informs design of safety and the infrastructure around it, or how it can be used to encourage behavior change. And largely this data is not easily available. Data that is available is quite quantitative. It needs to be combined with other data sets, but also this contextual data, what we're calling qualitative data, as informed by cyclists inputting this data into the apps. And that ability to combine both this quantitative and qualitative data together enables insights beyond what is currently possible. What we've showed today is that we've got a trialed and tested data-driven innovation process, really ensuring that this brings the stakeholders their needs with us, which ensures that the AI and data is relevant to the stakeholders, enabling creating value and creating real differences. In this example, it's around safety that's been picked up in there. And we've tested this process in manufacturing industries, foundational industries, and also in detail here with See.Sense and the safety elements of cycling and infrastructure around it. We can see that combining the data sets can be really of value, and these are informed by the different needs. It allows us to reuse data in multiple ways, and the AI is currently being used to identify changes in population routes, identifying potential abnormal events, combined with the contextual data, enables insight to be gained that cannot be otherwise. We can see that the concepts were developed into prototype dashboards and has been picked up by at least 3 different councils in there. So those are some of the progress to date and the impact that we've seen around here. We would also say that we'd like to acknowledge the wider team and our funding body, so the wider team of DigitLab and See.Sense, who've been instrumental in here, EPSRC, and in the innovate project, it was actually EU funding that supported that particular project, and Carl Johnson and Boyan, who particularly supported the early phases of this project. On understanding design and data in design thinking, and how to support digital age, we have a book that's almost ready to come out, Cambridge University Press, that brings these sort of issues to a wider audience, not just designers and not just AI or data scientists. And a podcast that we've brought together that's bringing together design, technology and innovation and entrepreneurship, because we recognize there is a gap in this area. We're pleased that Irene is going to be doing one of those case studies very shortly, so we'll have more insights on that journey on how you can use data for entrepreneurship, but also for innovation in our focus. Thank you very much. And thank you, Irene, as well.
Thank you.